All right. Since now we already in 9:05 Indonesian time and 10:05 Philippines time, I think we can start this online joint class now. All right. Good morning from Indonesia and very warm greeting for each and every one of you. Thank you very much for attending this class. This is the second online joint class between Telkom University Indonesia and Batangas State University Philippines. This is also the first collaboration between two universities since we just signed the MOU last month, I guess. It is a pleasure and honor for me to welcome all of you to this wonderful collaboration. My name is Lia Marlia from Telkom University's International Office, and I will be your chairperson today. Good morning, Honorable Dr. Renato Agamboa, Dean of College of Engineering, Architecture, and Fine Arts, Batangas State University. Thank you very much, sir, for attending to make time and attending this online joint class. It is an honor for us. And also, good morning, Dr. Ezel Gamab. Mr. Ezel Gamab, the Director of External Affairs of Batangas State University. Hello, sir. I hope you well. Good morning to Ibu Indah Hajarwati, Head of International Office of Telkom University.
Hi, good morning.
Good morning. And of course, all participants from Batangas State University, Telkom University, and other universities who join us today, welcome. We would like to extend our deepest gratitude and appreciation for your presence today. The topic to discuss in the second session is deep learning. But before we start, as usual, I would like to read some basic rules for the participants. Number one, all participants kindly turn off the microphone during the opening and presentation. And number two, should you have any question during the presentation session, kindly drop your question in the chat box. And number three, kindly turn on your camera feature in the group photo session. Number four, at the end of the session, we will share a feedback link in the chat box. All participants kindly fill the questionnaire in order to get an e-certificate. Please note that only participants who fill out the questionnaire that will be sent the e-certificate. All right. I will read the brief CV of the first speaker. As I mentioned before, that today the topic for today is deep learning, and we have two speaker today. We have Dr. Jeffrey Sarmiento. He is an assistant professor in Batangas State University College of Engineering, Architecture, and Fine Arts, who's also an instructor. His field of specialization is microprocessor, AI, and networking. And he got his doctoral degree from Doctor of Engineering School, Technological Institute of the Fields, graduated in 2020. Our second speaker is Dr. Syamsul Rizal from Telkom University, and he will be our second speaker and will be presented after Dr. Jeffrey S. Sarmiento. So everyone, please welcome Dr. Sarmiento.
Hello, everyone. Good morning. So, am I heard? Sorry, sir.
Yes.
Can you hear me?
Yes, we can hear you.
Yes, sir. Yes, sir.
Sorry. Yes, sir. Okay. Thank you very much, guys, for such a good introduction. So, I will be in charge, or I am in charge with the two introductory topic, which is the introduction to machine learning, and also the introductions to exploratory data analysis, or the ADA. So, allow me to share my screen first. Is it already shared?
Still loading. Yes,
Yes.
now we can see it.
Okay. Thank you very much again. So again, my name is Dr. Jeffrey Sarmiento. So I am in charge with the first topic on this session. So the first topic will be again the introduction to machine learning and the exploratory data analysis. So without further ado, so let me start tonight's discussion. Okay, so the first thing that we need to know is to define what is machine learning. Actually, machine learning is able to learn. So what we are going to define is what is learning. So again, learning, according to, actually this is according to Herbert. So he said that learning is a process by which a system improves performance from experience. So that means based on Herbert Simon, so we can only learn by experience. So yung learning, the learning will be
Hello, Dr. Sarmiento. I think you have a connection problem. All right, everyone. I think our first speaker has a connection problem. We will wait for him to rejoin us.
I'm sorry about that. I think I got disconnected. So again, let me share again my presentation. Again, I'm sorry about that. Okay, let me continue. So again, by definition, so learning is a process by which a system improves its performance from experience. So that is according to Herbert Simon. But according to Tom Mitchell, so machine learning is a study of algorithms that the first thing is to improve performance at some task T with experience, with experience, or we denote that as E. So that means learning is a process from which we want to improve the performance, let's say, performance of a system or a program, by which performance in performing such a specific task with experience. So experience can be from the previous experience. So that means that is from the existing data set or existing data from our databases, and also from experience during the processing or the execution of the program. Okay, so that is why usually machine learning do have its own optimization method. It optimizes itself to improve its performance. Okay, so a well-defined learning task is given by the variable P, T, and E. So what is the difference between the traditional and the traditional machine learning and the traditional programming and the machine learning programming? Actually, the main difference is that in the traditional computer programming or in traditional system, so we in our input would be our data and also the program. So the program created by a programmer, and of course using the combination of the two inputs, so we can generate a specific output. However, when we say machine learning, so the program is our output, because in machine learning, the program can adapt itself, can adapt on different users. So our input here will be the data and also the previous output. Okay, so the previous result of the previous operation. So it is always considered, or the previous result is always considered in our programming or in our traditional program. Okay, so why do we need to use machine learning, or why use machine learning? Okay, so machine learning, actually machine learning is oftenly used when the first one would be the human expertise cannot be used. Let's say, for example, you need to do some job or some task on a place whereas human cannot survive. or on some place, whereas human cannot be in that place because let's say, for example, it's so dangerous for a human to be in that place. But you need an intelligence of the human to perform a specific task. So that is where the machine learning will take place, or the machine learning will be used. Another one is to develop a system that can adapt on individual user. Let's say, for example, generally or by default, our system will perform a specific task assigned by any programmer. However, if you want to create a system that can adapt on different users, that can adapt on different environments, so machine learning is best used for that system. So another one is replacing human in doing monotonous tasks that requires human intelligence. So the best example for that is analyzing handwriting. So analyzing handwriting is so hard or so complex to analyze if it is only done by a human. But of course, the machine, given the power of the machine and also the machine learning algorithms that that we use, so we can do those tasks or those complex tasks easily. Another one is, let's say, for example, there's a big or huge amount of data in an organization or in an industry, or let's say, for example, in the internet, and you want to find something on that data. Okay, so that can be easily done by machine learning. So analyzing those huge amount of data is a simple task if you are going to analyze that using actually any machine learning algorithm. And then another one is, let's say, for example, there is a job or specific task that you want to give to the machine. However, this machine or this task can be performed by a human in more accurate manner. However, the human cannot explain how they perform that. Let's say, for example, the speech recognitions or the sound recognition. So by default, we know we can classify, we can recognize, we can distinguish any sound. However, we don't fully understand how we do that. And if that is the case, so we can give that to the machine. Using machine learning, the machine can analyze, can distinguish, can find features or patterns on that sound that makes us or that enables us to understand and use that technology for those specific tasks or job. Let's say, for example, the speech recognition. And then the last one would be developing a system that's too difficult or expensive if done manually. So actually, there's systems or applications or hardwares that can be developed using a person with special skills, let's say, for example, special trainings to do that job. However, it's not so easy to find those persons. So if that is the case, so we can just find the expertise, get those knowledge from them, and then create a machine or create a software or systems that can imitate or can mimic the special skills of those persons. So that is actually some of the common applications of machine learning. And of course, there's a lot of other applications of machine learning. So if you want to learn about machine learning, so you can find so many tasks or applications of machine learning. However, there's a question. So why using machine learning now? So why is it only now? Why we don't use machine learning during the previous days or previous years or past years? Actually, because of the huge amount of data, unused data in the internet, or actually in the industries, so there's a need to use machine learning to find out something or to find insights on those data. Another thing that hindered the use of machine learning during the past years or the previous years is the computational powers of our computer. So high power computers from the past, it's so expensive. Unlike now that you can find a high power or high computational power computer, even though these computers are cheaply in price or cheap in price. Okay? The third one would be... Sorry. The third one would be there's a continuous development on the algorithms and also in theory. So more and more researchers are developing or finding some algorithms that can help us analyze accurately those those data that is present right now. Okay. So, and then of course, the most important one is that the industry supports the research, the development, and the applications of machine learnings on different jobs or different tasks that they perform. Okay, so what are the problems that is best solved in machine learning? So if you want to apply machine learning, then I think these are the problems that is best suited, applied, or best suited that machine learning is applied. So the first one would be the pattern recognitions. Let's say, for example, the facial features. So if your job, or if your application would be to recognize people's, let's say, for example, in a certain environment, let's say, for example, you don't want any biometrics, or you don't want to waste time in registering in the logbook, let's say, for example, in our guardhouse before entering the university. So you can use actually the facial recognition to recognize those people, those students and teachers and employees in the university, so that you will not going to log in, log out, or whatsoever manual task, but you just need to pass through a camera, and then the camera will automatically analyze your or analyze your facial features, and then classify you as this person or whoever you are. So that is one of the applications. Another one is the handwritten words or handwritten numbers. So actually, this is a job for actually OCR is something that can recognize those texts, those images into text. However, when it comes to handwriting, so we have different handwriting. So you can use machine learning again. You can use machine learning to identify the words or the letters that is written using our handwriting. So there's a different type of handwriting. So we need really a lot of data to do that. However, if that is the case, so machine learning is the best technology to the best technology to use. Okay, so another one is the speech recognition of spoken word. So actually, there's a lot of applications of speech recognitions in our environment, or actually in the world today. So let's say, for example, our mobile phone or our smartphones. So usually it does have the application of speech recognitions. If you know Cortana, Google, Alexa, and what's the name of Siri, the Siri of the iPhone. So those are the speech recognitions, which is usually done or developed using a machine learning algorithms. And of course, the classification of image. Especially, let's say, for example, you want to what do you call this? You want to create a prototype or a device that is especially made for blind persons, and you want to identify, to detect those objects in front of you. So image classifications is the best algorithms to do that, and that is also part of a machine learning algorithms. Another one, so another important one is the pattern generation. So if you are planning to invent or develop autonomous vehicle, so of course autonomous vehicles created a pattern of the way that you need to follow, so that you will not going to bump any car in the streets, or you may not be out of way. Okay, so that is one example of pattern generation. Actually, that is also applicable in what do you call this, in DNA, in identifying your DNA, or in genetics engineering, or whatever applications that need a pattern generations. Another one is anomalies detection. So if you want to identify any anomalies on, let's say, for example, there's an event and you want to identify if there's an anomalies with that event. So using those data that you have collected, so you can identify any anomalies using machine learning. And of course, predicting and forecasting. So if you do have data that is reoccurring every time or every year, so you can see, or you can find any pattern, or you can check for any pattern on that, and then predict the future values, or forecast for the future values or for future data. Actually, it is best used, let's say, for example, for forecasting a cryptocurrencies or forecasting the stock market. Okay? So we use machine learning for that. Okay, so the main concept of machine learning, as I mentioned earlier, is learning is improving based on experience on some tasks. So usually, let's say, for example, let's say for example, as spam filtering in our email application. So spam filtering, our task here is to filter spam messages. So how do we know that we perform well in our task? So that is by identifying the percent of accuracy that you identify spam and the percent of accuracy that you identify those spam or the not spam messages. So how do we know whether the message or the incoming message or incoming email is a spam or not? So that is based on your databases of those spam messages. Or actually, you can also add messages, or you can also add text that you consider as spam in our database. Okay, so that is just an example. However, there's a lot of applications or a lot of examples that we can find that uses machine learning. Okay, so this is the complete process of machine learning. So of course, in machine learning, the first thing that we need to actually our main job is to analyze our environment and produce some results that will or that will be beneficial to our environment. So our input here, of course, the main input is the environment, and then our output will be applied also to the environment. So from the environment, so we need to have a sensor, especially if we are making or if we are developing an IoT based, let's say IoT based systems. So we need to have a sensors, or sometimes we just need to have a databases, whereas we can store information, store data that we want to analyze using or we want to use in our machine learning application. And then the next step will be the data pre-processing. And then we have the next step will be the dimensionality reductions, the data explorations, and then we have the modeling, machine learning modeling using different algorithms or using the algorithms that you want to use. Actually, you can also use ensemble algorithms or ensemble models. So it is for you to decide. And then, of course, we have the model training and testing. So that would be testing if your model or if your algorithm or collections of algorithm performs well on this specific task. Okay, so maybe I will just give some details on each part of our machine learning process. So our first example would be the sensors or the sensors or the databases. Usually, even when it comes to the example earlier, our database in that for the spam filtering will be the data set from the email server. So the email servers have the collections of those spam messages or those messages or emails that is considered as spam. So the next one would be data pre-processing. So the task in data pre-processing can also include data labeling. Let's say, for example, you are performing a supervised modeling or supervised machine learning, whereas you need to have a proper label for every data that you have in a data set. So you can label that using the data pre-processing, the normalization and rescaling of data for easy processing. And then we have the resizing. So let's say, for example, in image processing, sometimes you need to resize those images for easy processing or to reduce the computational power. And also the data cleaning. So as data scientist says that raw data is a dirty data. So you need to arrange that, to clean that so that it will be usable for your future work. And then the next, this is an example or a sample data set or a sample of the clean data set. So data set should have the input attributes and the target attributes. So again, using data pre-processing, it is for you to decide which attributes will be the input attributes or the target attributes. And then of course, the number of data sets that you have would be the number of instances of that data. And then of course, you also need to consider the different type of data that is present in your data set. So is it numeric, is it a nominal, or is it an ordinal data? Okay, the next step would be the dimensionality reductions and the data explorations. So data explorations, to summarize data explorations, it means identifying data points and getting insights from your data. As we all know, you need to understand before we perform any operations, any processing on our data, we need first to understand what is our data, what is our data set. And of course, before performing any learning, any modeling, so we need to reduce the dimension of the data. Actually, this has something to do with the computational power. the limited computational power, and also large dimension. If we have a large dimension of data, so sometimes it causes poor training of those model. Okay, so usually also in dimensional reductions, we have the feature selections and the feature projections. And then another one, the next step will be the modeling. So actually modeling includes different algorithms for classifications, for regressions, and clustering. So that would be discussed later by another speaker or by the next speaker. So also includes the hyperparameterization, let's say the number of nodes, the number of layers, the number of kernels. It depends on the algorithms that you are using. And then also the normalization algorithms, or we commonly set as activation function, whether it's sigmoid or hypertangents or rectified linear units, and also if there's a dropout in our, so everything is done using modeling. And then of course, after modeling, so we just need to test whether our model performs well in doing the specific task that we want to perform. So that includes identifying different backpropagation algorithms or optimization algorithms to ensure that that our model will be optimized well or produce good results. So there are a lot of algorithms for backpropagation. So some sample is presented in the presentation, like the gradient descent, the stochastic gradient descent, and the adaptive movement. So there's a lot of optimization algorithms. Okay, so so that is the process, the general process of machine learning. And then of course, we have different learning algorithms. So I will just summarize the learning algorithms in their depending on their groups. So let's say, for example, the first learning algorithms that you can use actually in machine learning is those linear classifiers. So let's say, for example, we have this kind of data, data with two classes. So we have class orange and the class blue. And then using linear classifier, we just need to find a line, whereas it's separated, or it will separated by a straight line. So it can be that line, or it can be this line, or it can be that line. So it is for you to decide which line will best describe our data set. So that is basically the idea of linear classifiers. And in our linear classifiers, we do have what we call the classifier margin. Actually, classifier margin, this is the border on which you can assign a points or a border points for every data in our data sets. So actually, one of the algorithms, simple algorithms that we can use using linear classifier is the maximum margin linear classifier, or actually it is also called the linear support vector machine. Actually, this is the simplest kind of support vector machine. So you already heard the support vector machine. So that is, that algorithms is also a part of linear classifier. Actually, regression is also a linear classifier. Okay, so however, there are some data that is the border is not, or data that is not separable by a straight line. So this is an example. So if you can see the boundary, so if you provide a straight line, there are some data that is supposedly not included in other classes. So if that is the case, so instead of a straight line, so we do a or we create a non-straight border. So that type of learning algorithms is called the nonlinear classifier. Okay, so we have linear and then nonlinear classifier. However, there's let's say, for example, we have to decide whether we use a linear classifier or nonlinear classifier. So what are our constraints and the trade-offs? So let's say, for example, for the nonlinear classifier, we have a perfect accuracy. However, it is so complicated. So it's so complex. Maybe it can take more time to process that. It can require a more computational power to process. However, so we have here the linear classifier, which is more simple, can be easily implemented, can be processed in a short period of time. It doesn't require a large or doesn't require more computational power. However, it is not that accurate. So that is our constraints and our trade-offs, whether we are going to use a linear classifier or a non-linear classifier. So it depends, of course, on your applications. It depends on the available devices or the available hardware. Okay, so Another case is the nonlinear separable cases. So those cases that not separable by linear or nonlinear classifier. So the only thing that you can do to separate that is to what we call this to draw a line which is separated the other classes to the other classes, which is that line cannot be linear or not linear. I mean, cannot be aligned. Okay, so this is the main idea of those non-linear separable cases. So in that case, so we use algorithms which is we generalize as lazy learner. Okay, so these are the instance-based learner, and then generalization beyond the training data is delayed. So one example of the lazy learner is the k-nearest neighbor, or the KNN. So if you heard the KNN algorithms, so the k-nearest neighbors only identifies each neighbor. So usually it identifies neighbors with similar or most likely similar cases or similar in any sense. So usually in k-nearest neighbor, we identify how many neighbors that which is similar in some sense do we need to include in our cluster. Actually, this is used for clustering. And another one would be the decision tree. So decision tree is just like or it utilizes tree or graphs. So we have nodes, branches, and leaf. So actually, decision tree is just like a search algorithm. So if you already have the data structures and you already they already discussed to you about the search algorithm. So it's just like a search algorithm. However, it has more complex because it identifies whether your group includes a or whether your group has more classes or more class A than class B, and then you identify just as class A or class B. So and then you traverse on all the nodes of the tree, so to identify what is the best groupings that you can provide in your data set. So actually that is part of lazy learner algorithm. So under that is the decision tree. Of course, in our machine learning or in our learning process, we have what we call the overfitting and underfitting. So when we say overfitting, so the model learns the training set too well, so it overfits the training set that performs poorly on that test set. So the learning of our training data is too well, so that the results of or actually the test results would be or will be poorly or not accurately done. Okay, so when we say underfitting, so the model is too simple. So your model is too simple that it cannot produce any good results. So there's a large amount or huge amount of errors in that training or testing. Okay. Okay, so another good thing about machine learning. So it does have actually an algorithms that mimics the human brain. So that is why it is called a neural network. So actually, this is just an example of a neural network. So the main concept of our brain and the main concept of a feed-forward networks. But anyway, the next, I think it is already included in the topic for the next speaker. So I will leave that for now. So I will proceed to dimensionality reduction. So what is dimensionality reduction? So we say that less is more. Okay. So that is why to ensure that there are several samples for each combination of values, the learning requires a huge amount of data set. However, predictive power reduces whenever there is or whenever the dimensions of the data is increases. So that is why we apply dimensionality reductions. So actually, in applying dimensionality reductions, so we preserve the properties and structures of the object while lowering its dimension. However, there is actually drawback in using the dimensionality reduction. So usually dimensionality reduction distort our data, and it could lead or those distortion may lead to a wrong result or a misleading result. So we cannot say that the result is wrong. However, it can be misleading to us. It can be misleading to those who are performing those processing or performing those applications. Okay, so generally we have two types of machine learning. So we have what we call the supervised and unsupervised learning. So when we say supervised learning, so let's say for example, we have a multi-class multi-class data set or multi-class data. So usually in our supervised learning, we created a label for each class. Let's say, for example, in our examples, we have three classes in our data set. So the class orange, class red, and class blue. So that means during our training, the system or the machine will already learn what is common on a specific class. Okay, so actually supervised learning, you just tell the computer or you just tell the program what is the pattern of each classes, so that the next time that I will give an input, the next time that I will give a data, unknown data, so it can already analyze those data and assign it on a specific class. So usually in a supervised learning, you cannot assign classes or you cannot add another classes or you cannot add more classes other than the classes that is already defined in your data set. Okay. Okay, so another type of supervised learning is the regression. Okay, if you have data set that can be represented of by a single line or actually linear line, so you can use regression analysis on that. Actually, that is basically one of the algorithms we use in forecasting data or forecasting future values if your data is linear. Okay, so if you can still remember in our statistics, the linear regressions, polynomial regressions, and what we call the other, the multi-linear regressions, that is one example of a supervised learning. So how about the unsupervised learning? So unsupervised learning is learning without any idea of what are the classes of data. So that means in supervised learning, you assign a set of observation into subset, whereas observations on a cluster has similarity on any cases. So you don't have any classes at first on your data, and then based on the analysis of those data, so it groups all the data with similar cases or with similarities. So those groupings are called clusters. So usually clustering algorithms are part of or are example of unsupervised learning. So actually one of the dimensionality reduction algorithm, which is the principal component analysis, can be considered also as unsupervised learning algorithm, since it do clustering. You can use principal component analysis for clustering of data. Another applications of unsupervised learning is the anomaly detections. So when we say anomaly detection, so it enables to determine patterns on our data sets that doesn't conform on the normal behavior. Let's say, for example, in the graph, so we have here group A, group orange, or cluster orange, cluster red, and cluster blue. And then you can easily group that because they are on the same area. However, there are some points of the cluster red that is far away from the other data. So those are the anomalies in our data set. And of course, you can use unsupervised learning to identify if there is an anomaly on your data set. Principal component analysis is also one of good algorithms for that. I already done some research that enables me to identify any anomalies on my data set, and I use principal component analysis to do that. Okay, so that would be all for the introductions of machine learning. And now I want to proceed. I understand. Sorry for I don't know if I am going too fast in my discussions, but I actually try to compress my time so that I can finish everything in 45 minutes. But I think I don't know, maybe am I going too fast or is it okay?
You still have 10 minutes, Dr.
Yeah. So of course, okay, so let me proceed to another topic that is assigned to me, which is the exploratory data analysis. So actually, exploratory data analysis is just an initial thing that you need to perform before doing some algorithms or before applying some machine learning algorithms. So what is exploratory data analysis or EDA? Actually, EDA refers to the process of initial investigations of our uh, data set. So it is used to discover. Actually, it is used to discover pattern, to find anomalies, to test your hypothesis. If you have an hypothesis and you already provide or you already perform some experiments which gathers some data, and then you want to test if your hypothesis is right or wrong, so you can use EDA for that, and also to check your assumptions. Okay, so usually EDA uses statistical method and graphical representation. So when we say statistical method, just some simple statistical processes that we perform on our data, and also we represent those data in a graphical manner, okay, in a graphical representations. So another one, we use EDA because it is said that it is a good practice to understand your data first, or gain an insights from your data before doing some predictions, classification, and forecasting. So EDA mainly uses we perform EDA mainly to for us to have a better understanding of our data, and also to have an insights with all those data sets. So some of the importance of EDA is, the first one is to identify important variables or features in your data sets. So the only thing that you can identify those features is by looking closely on your data, and that is what EDA is. Okay, another one is to identify any outliers in the data sets. So by graphing or by graphical visualizations of your data, so you can easily identify if there's an outliers on your data set. The third one would be testing for hypotheses, as I said earlier. So, and then checking the quality of data. So again, our data set may not be that good, or may not be of good quality if we need to test that, or we need to check that first before we perform any processing or any applications of machine learning algorithms. And then, of course, to find unexpected structures or insights of the data. So let's say, for example, you don't have any idea on what is present, or what can be learned on this data set. So using EDA, so you can find unexpected structures, or you can find insights on your data sets. So this is the complete process of the EDA. So we have the first one is to distinguish attributes, and then we may perform univariate, bivariate, or multivariate analysis. And then the step 3 would be to detect interactions among attributes, and then detect aberrant or missing values, detect outliers, and feature engineering. So these are the processes that can be or this is the processes in our exploratory data analysis. Okay, so the first thing that we need to understand is what is the structures of our data. So that includes the number of data points, the features, feature names, and also the data type. So whether our data is a nominal data, or sample of that is those data in categories, let's say marital status, type of car owned, and then we have the ordinal data or ordered categories. So it can include rankings, orders, or scaling. So examples are those service quality ratings, student letter grades. And another one is the interval data. So actually, this is the difference between measurements, but no true zero. So that the example of that is the temperature in Fahrenheit, and or the temperature itself, or the standardized exam score. And then, of course, we have that what we call the ratio data. So difference between measurements through zero exists. So it can be height, age, weekly food, and weekly food spending, and any numbers that can be represented using ratio data. Okay, another thing that we can do in EDA is a univariate analysis, or one example of that is the measures of central tendencies. So we already know this, the measure of mean, the median, and the mode. So actually identifying that what applications you want to use in our data set. And then another one would be the bivariate and the multivariate analysis. So let's say, for example, you want to so actually this is used to measure the spread of data. So one of that sample is the range, difference between the smallest value and large value of data set. However, there is a better measure of the range, which is we include the positive values and negative values that can be identified for that range. Okay, so the positive and negative range. Actually, this is used to identify abnormalities. So we call that as the standard deviations. Actually, we in statistics we always find the standard deviations. And then of course the quartile, the deviations. You can also do that in exploratory data analysis. So this is actually the spread of data around the central region. Another one is to represent your data or to find the kurtosis and skewness. Sorry for the typographical error. So this is skewness of our data. So what is skewness? So actually this is the measure of symmetry. So whether our data has positive or negative skew. So this is an example in our illustrations, the illustrations of negative skew and the positive skew. So usually we test if there is asymmetry on our data. And then another one would be the kurtosis. So the kurtosis, actually, what we are checking in the kurtosis is the tail. So whether our data has heavy tail or light tail. Okay. And then of course, And then of course we have what we call the outlier detection. So actually, as I said earlier, so outlier detections can be better, or we can be better find the outliers if we are going to present that in a graph. Okay, so this is one of the this is one of the example of identifying outliers. So we have here the data, and the data can be represented on a single line. However, there's a data that is outside the line or far away from the line, so that could be an outliers, and that is another thing that can be identified in our exploratory data analysis. So usually in exploratory data analysis, we do have visualizations or visual aids. So actually, visualizations easily help us to understand our data or identify any anomalies or any unusual pattern in our data. Okay, so the most common used visual aids is the histogram. Okay, so histograms, it usually represents underlying structures in the form of frequency distribution. So that is how often a particular value occurs. So usually, histogram is similar to a bar chart, while a bar chart has bars for individual values. In a histogram, it is more common to group together a range of values into a single bin. So often 5-15 bins should be considered depending on the range of the values in the data set. So with too few bins, the graph will not detailed enough to interpret the distribution. So in fact, due to binning, histograms can plot both categorical and continuous variables. So bar charts are only for categorical variables. So histograms help us see data symmetry. So fix outliers or data error through omission. So if you can see in the figure, so we have two peaks that imply two distinct classes. So actually, you can add additional peaks on this histogram. So it depends on how you want to view your data. So another one or another common representations that we use in our data is the scatter plot. So this is actually plotting two variables and see the underlying relationship between these two variables. So actually, a scatter plot can reveal data symmetry, clusters, correlations between variables, and extreme values or outliers. So as we already seen from every slides that or from the previous slides that I presented, so we already see a scatter plot, whereas we can identify outliers, we can see the clusters or correlations between variables. Usually the plot is a series of dots scattered in 2 dimensions. So often a line is drawn across these dots, so the line doesn't connect the actual points, unlike the line graph. So actually we usually put a regression line in our scatter plot so that we can be used as predicted tools, or we can use this graph or this scatter plot to predict something or to identify if you can really predict something in this data. Okay, so another one would be the pair plot. Actually, pair plot is it helps us comprehend the underlying structures of the variable and its relationship with other variables on a single visual. So relationship with of the variables with other variables, and then in a single visualizations. So usually it is a combination of a scatter plot in the histogram. Like in this example, so we have two types of graphs here. So we have the scatter plot in the histogram, so to represent our data. And then of course, before we perform, actually, it is something that we always find difficult to analyze is those data with complete informations. So what do we do in those data? So usually we do what we call the imputations. So this is usually an estimations of missing values before proceeding to data analysis. So we estimate the possible values for that missing points or missing, let's say for example, this is a Excel data. So there's a cell that is which has missing value. So we do have estimations of what we are going to put on that missing values, or we need to decide whether we are going to estimate a values for that, or we just remove the whole rows, whereas there is a cell that has no values. Actually, it is for you or for the analyst to decide what to do with that information. Okay, so I think that is all for my discussions. I think, yeah, I am done. So I think I'm done with my discussions, and we can proceed now maybe to our next speaker.
Yes. Okay, thank you, Dr. Sarmiento. It's been a very interesting presentation, yeah. All these machine learnings and AI talks is always take me back to the Terminator movie. And it's kind of a little bit scary, but also since I saw your presentation, so I know more about the advantage of this machine learning. So we are moving on to our next speaker, Dr. Jeffrey. Can you please unshare your screen? Or yes, thank you very much. So our next speaker is Dr. Syamsul Rizal. He is a lecturer in Department of Electrical Engineering in Telkom University. He got his doctoral degree from Kumho National Institute of Technology, South Korea. His research field currently is in the machine learning and digital signal processing. He is a CCNA trainer for training the student about basic network. He also has experiences in handling several projects that are funded by the Indonesian government. Dr. Syamsul Rizal, can you please start? Okay, thank you.
Okay, thank you for the time. I will share my presentation. Can you see my slide right now? Okay. Thank you, Ms. Tia, for the time, and hello everyone. It's nice to meet you all. Actually, I'm a little bit nervous right now because this is my first time to do this online joint class with International University in Philippines. Okay, let's start our discussions about regression, classification, and CNNs. But actually, Dr. Jeffrey already explained about the linear, about regressions is about linear, and a little bit about neural networks and the gradient descent. So I will try to explain in my way. I hope I will try my best to do the presentation as simple as possible so you can understand about what is regression and what is classification and what is the CNN. Okay. Okay, let's start. My name is Syamsul Rizal. As Ms. Lia told you about my backgrounds, I did my doctoral degree in South Korea in Kumho National Institute of Technology, and my research area is embedded system and machine learning. And if you want to contact me, you can contact in samsul@telkom.university.sg.id or samsulrizal123@gmail.com. Yeah. Okay, let's start about these regressions. So has anyone seen a crime show or heard of an investigations where they use a footprints to determine a suspect height or the weight? So it's a tactic frequently mentioned in connections to forensics. But actually, does it actually work or not? So we have some data. The data is the footprint size, and we try to plot this footprint size to predict about the suspect height. Here, for example, like 1 meter or 1.5 meter and the others. Okay, but actually they use this kind of method, for example. So here's the mathematical model about these regressions. So linear regression has a simple goal. The simple goal is to find a straight line that best fits a set of data. So recall that the equation for a line is y equal, actually this is a mathematical things because of regressions, but this is a simple. I hope you can understand. So this is the model. Y is equal m multiplied by x plus b, where x here is denotes like the input or the input variable, or you can say features in machine learning, and y is the predictions or our outputs. In the case of machine learning, as the input feature, and y is the target output or the prediction output. Okay, so if you were trying to forecast, for example, like the energy level from coffee intakes, so amount of coffee would be the input and the energy level would be the output here. Okay, so this is the coffee intakes, for example, like 1, 2, 3 cups and the other cups, and this is the energy. I'm sorry, I just captured it from my slide and it couldn't see clearly, but I will, if you want to do to get my presentation, I will try to change the figure. So using the data, simple linear regressions learns two value. The first is m. The first value is m, which you may call slope in this case, and which we will refer to as a weight or coefficient. And this represents how much a change in the feature value x should affect our prediction y. Okay. And in other words, a 1 unit increase in x yield an m unit change in y. The second is b. The second parameter is b, and which you may have called an intercept, and which we will refer to as a bias here. And the bias represents the predictions we would make if our input features are all zero. For example, you may expect yourself to have low energy without any coffee, but probably not a zero energy. You still have some energy even though you are not consuming coffee. So that's the bias. So you still have some value here. That's the bias thing. And that's only one feature. So what will we do if we have multiple features? So realistically, the energy level might depend on several factors, maybe like the coffee, time of day, and temperature in this case. So now our model needs to learn 3 weights. So M1, M2, and M3 is all of this is the weights, and one for its input features, and plus one bias here. The concept of weight and biases is important to most machine learning models. So you have to consider about this weight and bias. So even complex neural networks, they still use weight and bias, okay? And the model uses data to learn how its input feature, this is the feature, affect the output, the energy level, and it learns a bias. It will learn this bias and weight to linearly shift its prediction to fit the data. Actually, that's the main idea of the linear regressions. I hope you understand about this simple mathematics. Okay, so let's do the machine learning process. Actually, but how do we learn the weight and bias? In machine learning, it means that the model learns some the parameter is weight and bias, M and B itself. So typically in machine learning, we use the following iterative process. First, given an input value, and we forecast or guessing the potential target value or the prediction value. And we calculate the error. The second part is we calculate the error or differences between the actual target value with the target we guesses or the prediction target. The actual with the predictions. After that, we update the weight and biases to produce a guess that is closer to the actual target. So it's go to this train or learn part. So the model is learning to update the value of weight and biases here. And then we iterate or repeat it, and this type until some stopping point conditions. For example, like the stopping condition could be a small enough error. We want to get the error as small as possible in this case, because we calculate the differences between the target and the actual target and the prediction target. I will give the example. So here is my examples to predict the selling prices of a house here. And we have 4 data points. The vector X value is the square footage of a house or square feet of a house, and the target or the Y value is the price of the house. So here is our data. You can see it's our data, and we will use these equations to make some linear regression or the line to fit this data. Okay, here is the different depiction of the same 4 data points. The previous table. So here's the data point. We have 4 data points, the blue dot here. So it is only a simple scatter plot where the x-axis is the size of the house or our feature X, and the y-axis is we have the price of the house of our targets. Maybe it's in US dollar. So to begin the iterative machine learning process, we make a guessing at a weight and biases. So it's like the random. You can choose your weight and your bias. But in machine learning or in your computer, the computer will choose the weight and biases randomly. Okay. In this case, let's assume that we have one weight M and one bias B, and we can guess that the M is 70 and B is 100,000, for example. Just guessing, okay, based on this data. And here is the line. After we get this M70 and B100,000, we now have an initial guess for our model parameter. And we create the line Y equal MX plus B, where M is 70 and B is 100,000. So this is the line, okay? And then after that, we try to predict our targets based on this line. So here is our predictions targets. So we use the line to forecast predicted output value. For each point in our training data set is X. We already know about the X or the input feature, and we try to predict the outputs with our model. It means our model is this line. So this is our predictions, the purple color. And the blue one is the blue colors are the actual target input, okay? And here we have the actual target output, blue, and the forecast output, purple from our model. And then we completed the first steps, is to infer or to predict or the forecast step. Here, done the first step. After that, we continue to the second step to compute the error, loss, or the cost function. Yeah. Now we move on to step 2, and here's the step 2, which is to compute the error or the loss. We calculate the error between the actual target values and the forecasted values or the predicted value. The method we use to calculate this error, maybe we can simply use the Euclidean distance, but there are any other measure as well. So we will talk about error and cost functions maybe if we have do this posisi in another time, okay? But for now, it's okay to think of the distance between the actual value and the forecasted value, okay? So we try to calculate the differences between the actual value and the difference, the predicted value here. So how big the difference is? The bigger the difference is, it means the error, the bigger the error, and we want to reduce the number of error, and we have to get the smallest error as possible, as small as possible for the error. I'm sorry. That's the second step, and then the third step is finally we update to weight and bias such that we reduce the error here. Now we have a new B, and maybe it's likely move from 100,000 to maybe 150,000 maybe probably, or the slope it will be changing as well because we have to update M and B here. And after that, we do this repeat. I mean that we start at step 1 using this new parameter, and how big this value are changing is depend on the previous value and this learning rates actually. I believe that Dr. Jeffrey or Dr. Sarmiento already mentions about the learning rates in the optimizer as remember. So we'll talk about this. What is this learning rate? So this is how the machine learning process, infer, compute error, and training, and do this for several time, 100 times, even the million times until we get the small error. So we will talk a little bit about what is learning rates. And learning rate is a hyperparameter with a constant value with scale how far we tweak the value during its iterations. So what's the value? The value is the weight and the bias. So the weight and bias will be updated based on these learning rates. And how big our learning rate is depend on you. That's your model, so you can choose any learning rates, but actually learning rate is from 0.001 to 0.1, but it's not limited in this value. You can do your experiment by yourself about this learning rates number. I will talk a little bit about gradient descent, and Dr. Sarmiento already mentions about this. Stochastic gradient descent is one of the optimizer actually in machine learning. And how does the model iteratively update its parameters? In this case, we can think of our goal as an optimization problems, where we like to optimize or we want to minimize a loss function. So here is the loss function. And here is the weight. The weight. So the most common optimizer is gradient descent actually, and where the model start by picking random value for its parameter and then changes its in directions that reduce the loss the most. Yeah. So one is iteration or step. The model should get closer to the minimal loss until it converts. You can see that, for example, that we choose this random value and then every iterative or every step is reduce the number of loss here. But when it's closest to the bottom or to the minimized loss, the step will become more closer or small. It's like the baby step, maybe small and small, and then until it's converts, until the loss you got will have not changed significantly. Okay, and you can control the gradient descent by choosing the learning rate here. So this step is the learning rate. How big your model will be learning to tweak the model, to tweak the weight, and then to reduce the loss here. So this learning rate determine how much you tweak this parameter on each step, and we call this the hyperparameter. The learning rate is hyperparameter that the value can change the model performance, but one that is learned by the model, of course. That's all about the linear regressions. That only the simple linear regressions. And for the machine learning, you can do non-linear. Of course, this is only the example of linear regressions, and linear regression is to predict the continued value. For example, like the prices house, and what else about the like the energy level with the coffee you consume and the others. That's regressions. You want to predict the new number or the new value, and then you will get the result. Okay, after that, we will move to the classifications. I will try my best as well to explain as simple as I can about the classifications. Okay, classification is a very common machine learning model type fully. Classification and regression is type of the supervised learning, which means that our model or our data set have to the data will have a label as the ground truth, okay? Because it is called the supervised. It means that your model need the supervised to do some, this one is class A, this one is class B, and this one is class C, or the other class, okay? So classification systems determine which class or category an examples belongs to, and they can distinguish between two or more classes, minimum two class, okay? And more classes, of course. And these classes are defined based on your goals for the machine learning systems. Actually, it depends on your goals or depend on your engineer, the engineer's goal for the machine learning system. For example, to answer the questions, is this a lion? So you would choose the classes yes and no. It means binary classifications only have two classes, yes and no. And the problem of choosing between two classes, you can call binary classification here. And for another example, to answer the question, what type of cat is this? You may choose the classes like lion, tiger, and kitten or cat. So you have several classes, more than two classes. And if you have more than two classes, you can call it the multiple classification or multi-classification, okay? And classification can be used to identify object in images or even identify whether the credit card transactions are fraudulent or not, okay? That's classification. To choose or to do the classify some object or to classify some data set there. So this animation shows what a binary classification system is trying to do. And given data point from two classes, the green and the yellow colors, learn some mathematical function and that can separate the two classes and predict which class a new data point is in. Okay, and the system can predict which class to apply to new data after training on existing data label with the correct class. Okay, for example, that we have this kind of model, and our model have this line, and it differentiate between class green class and the yellow color class here. So if we have new data and our new data is here, so it in our system it will predict that our new data will go to the yellow class, because it makes the separations between the green and the yellow class. Okay, that's the classification. And classification model results are often treated as a list of confidence value. The model will predict the probability that the given data point is part of its class here. And in these cases, the model only make predictions, and your code will need to make decision based on these predictions. What class this image based on your code. Okay, and notice that these confidences do not necessarily sum to one. You can see, for example, our model say the tiger score is 0.96, or we can say 96.4% if you want to convert to percentage. Lion is 74%, cougar is 67%, and lynx is 53%. So it depends on your code if you want to put some threshold there. So your model or your system can decide which class is this image. For example, I want to do some model like I will choose the highest number from this value. It means that my system model will predict this image is a tiger because this is the highest value. Is the higher than the other classes like lion, cougar, mountain lions, and lynx. Okay. Actually, the probability, if you learn about the probability is between 0 to 1, right? But in this case, if you sum all of this, is not quite 1. So because this model, it's used like sigmoid function or the activation functions. Dr. Sarmiento already mentioned as well about the activation functions. But if you want to do like interpret them as the probabilities, you can use like softmax. Softmax is one of the activation functions to do some classification. So here the classification model, there are numerous models that can be used for classification, and some of the more common ones that you will see are mentioned here actually. Maybe some of you already used this model previously or currently, like the logistic regression is the variation of linear regression that perform regressions. Then you see some threshold to make a classification decisions, like the nearest neighbor, decision trees, random forest, naive bias, even deep learning. Deep learning here, it means that the neural networks trying to make classification decisions. We will explain. We will discuss about the neural networks soon after these classifications. As mentioned before, determining the performance of a regression model is calculated by measuring the distance between continuous values. Okay, that's the regressions. In the case of classification model, there aren't any continuous values here to measure. And we don't have a good definition of the distance as well. So instead, we count the number of predictions that the model got correct and number that were incorrect. Using these counts, we can then create various metrics that can be used to calculate model quality. And most of the performance measures that we look at will be based on value taken from the confusion matrix. So here is the confusion matrix. For the sake of simplicity, we will stick to evaluating model quality for like the binary classification, yes or no, good or bad, handsome or not handsome, or the other thing, okay? Or at least from the perspective of a single class. Think of the two classes is one positive and the other one is negative class in this case. So we have true positive, false negative, and true negative. So what it means? True positive means our model predict it's positive, but the correct class is positive as well. So it's true positive. We predict positive and the class is real positive. False positive means our model predict it's positive, but the correct answer is negative. So it's called false positive. And false negative, it means that our model predicts negative, but the correct answer is positive. Okay, and true negative, our model predict is negative and the correct answer is negative as well. So that's confusion matrix. That's simple. And based on this confusion matrix, we can calculate the performance metrics such as accuracy. Accuracy is very basic quantitative measure. It is simply the number of predictions that the classifier got correct divided by the total number of prediction made here. And accuracy seems like a reasonable thing to check, of course. Maybe if you do some project or make some model, you will choose the accuracy as your performance metrics. But actually, this accuracy isn't always a good measure in this case. This is especially true for skew dataset or the with class imbalances or imbalanced class for your datasets. For example, here, imagine that we are trying to diagnose an extremely rare type of tumors here. And in our training data, we have, where is it? 995 sample of benign tumor, and we only have 5 malignant tumor. So it's imbalanced data sets here. So total we have 1,000 data sets about the tumor here. And let's say we train a model. So we have a model here. So we have our model. And our model always predict false. It means that our model always say the tumor is benign. All data our model will say all is benign here. So it means that we have 1,000 data, and for the benign itself, the true is or the true positive is 995. So 995 here for our accuracy. So it means that we have the accuracies around 0.995. If we convert it to percentage, we will have 99.5%. Actually, from the perspective of accuracy, this is a great model, right? But in reality, there are some clear issues here, especially if we consider that we would be sending people with a tumor home thinking their tumor is benign. It's a catastrophe for us. Okay, our model will be not used for this kind of thing. So even with the balanced classes, accuracy is probabilistic. It has problem because it ignores the context here, and sometimes you care more about performance for one class over another class, depending on the consequences of your decisions and depending on your data set. Okay. You will use a different threshold to make the decisions. And for example, if you are predicting a disease that would require a dangerous or invasive surgery, you may require a much higher probability for your classification as positive than if it only require a recommending like the two experience, for example. That's depend on your perspective and depend on where your model should go. So this accuracy actually is not enough to measure your model is good or not. You have to find another matrix, and here is another matrix. I'm sorry, this is prediction score. This is the actual score still in Indonesia. I forget to check it. So this is another performance metrics that we can calculate. Usually, some researchers or almost all researchers will calculate this recall and precisions. And based on this recall and precision, we have some F1 score. But we will not talk deep about this metrics, because if we talk more detail about what is classification and what is regressions, I'm afraid that we don't have enough time to explain, to discuss about in detail about this. Okay, so that's all about the classification. So that's the differences between regression and classification. I hope you get it about the differences, because I try to use the simple example, and that's all about the classifications. And the third topic, because I do 3 topics here, we will discuss a little bit about neural networks. And like I said before, this is only small part of the machine learning and small part of neural networks, because if you want to discuss in detail about the neural networks, we don't have time. I only have 45 minutes to explain how to do the presentation for these 3 topics. Okay, so let's briefly discuss about this neural networks. I know you see this figure from slide from Dr. Sarmiento as well. So this is the following. This is the illustration of network modeling in the human brain. This one is the human brain, so that it can be implemented into a machine here. So in the human brain, there are some nucleus maybe, and the cell body, then the right axons and the synapses here. And this part of the brain can be interpreted as neuron or nodes, input, output, and weights on the neural networks model here. So broadly speaking, the input is data to be processed for node, which is influenced by the weight value, so as to produce a certain output. So this is the input. So this is the input, and we have some weight here, and you will do some maybe some activation function here to get some prediction output, to get the output. And we call this model as the perceptrons, which only have input and output layer. So we have single layer perceptron, input output without any layer in the middle of this layer. Okay, so this is the perceptron is the simplest model in the neural networks actually. How about multi-layer perceptrons? So this is the example of multi-layer perceptrons, or maybe you can say is artificial neural networks, or INN, or you can say is like fully cognitive layer as well. And for multi-layer perceptrons, it consists 3 layers. It's called input layer, hidden layer, and output layer. This architecture can also be referred to as a fully cognitive layer, as I mentioned, and the number of hidden layers can be adjusted to the complexity of the dataset to be trained. Okay, the number of neurons is a hidden layer is generally more than the number of neurons in the output layer. Generally, but it depends on you. If that's your model, you want to choose the number of hidden layer, the number of the node in its hidden layer is up to you actually. But you will see the result. It will be good or not. How about the accuracy there? Is good or not? Yeah, okay, that's the hidden layer. You can do your own model to add the hidden layer and to increase the number of nodes in your model. So here the artificial neural networks, or the ANN, to determine the number of neurons in the input layer, one must look at the data sets from the following illustrations. And our data set is an image with the size of 28 by 28 pixels. Okay, and because the fully cognitive layer is a model that has one-dimensional input, the input should be one-dimensional. Then we need to convert the image into a one-dimensional matrix form, of course. So we have 28 by 28 pixel. If we multiply it, we have 784 pixel for one-dimensional, for one image. And for this small image, 28 by 28 pixel, okay? And this value determines the number of nodes in the input of the layer, our input layer in the neural network. So we have x1 until x784 because of the number the image, the number of pixels in the image. You can imagine you have your mobile phone, and your mobile phone has high resolution for the image. For example, like 1000 or 2000 multiplied by 2000, for example. And if you want to use these neural networks, it means you have to convert it to one-dimensional, and you will have a million number of pixels there, and you have to put it in the input layer. And the number of nodes, it will become bigger. It is the massive node in the input layer. You can imagine if you use your image from your mobile phone. Okay. So here's about this CNN. So different from the NN or the networks, whose input layer consists of one-dimensional matrix. In a convolutional neural network, or we call CNN, the input is 1, 2, or 3-dimensional matrix. You can use dimensional matrix as well. So it's convenient for image. For illustration, the following is an example of CNN concept, whose input is 2-dimensional image with size 6 by 6 pixel here. And for ease of explanations, we assume that this pixel value in the image is 0 and 1. I'm sorry. And this image will be convoluted with a filter whose size we can specify. This is our filter. For example, the filter size used is 3 by 3 in our case, and to the filter size, we can increase the number of filter to 3 or 2, 3, 4 or more filter is depend on you. That's your model. You can choose the number of filter, is up to you. There is no limitation in determining the number of filter in CNN. So this filter can be referred to as weight on CNN. In previous neural networks, the weight is like this, right? So here's the weight number 1, weight number 2, and so on. If you have big data, big number of nodes, the weight will be increased as well. But in neural networks, the weight is only this filter, 3 by 3, or it means 9 number of weights for one filter. If you put 3 by 3 and you have 2 filters, it means that you have 9 multiplied by 2 is 18 filter, 18 weight here. So that's differences between INN and CNN. So these are the network parameter to be learned, and is filtered into a small pattern of 3 by 3. So how the CNNs works? So this is the illustration of the basic differences between convolution and fully connected layer. Okay. For example, in the convolutional layer, we have 6 by 6 input image, and we have 3 by 3 the filter size. And let's assume that we only use this one filter, and the value of the filter 1 is 1 and minus 1. To make it simple, okay. So the total weight that we use for this convolutional layer only takes 9 weights here, okay. And this is 9 weight, and this filter will be multiplied for the small part of your image. 3 by 3 as well is depend on your filter. Is your filter 5 by 5, it means it will calculate 5 by 5 pixel from your image, okay. After that, calculate and summarize. It will get 3, the value. You can calculate by yourself, right? So 1 multiplied by 1, 1 multiplied by 1, 1 multiplied by 1, and the other 0. Any number multiplied by 0 is 0 here. So 1 plus 1 plus 1 is 3 here. After that, you move to the next pixel of your image in this part. So it's like moving or shifted the filter until your filter move to all the pixel in your image. Done. And then you create this new filter or the new image here. So from the input image, you create the new image after doing some filter here. Okay. That's CNN. So how about the convolutional fully connected layer? So for example, like still same, we have 6 by 6 image, and we convert it to one-dimensional. So we have 36 node for input data or the input node, input layer. And for example, we have hidden layer, one hidden layer, and in one hidden layer we have one node here. It means that for only one hidden layer and one node, we have 36 weight, but in CNN we only have 9 weight. So the total number is big. The gap of number is quite big, right? For this example. Okay, so it means that the CNN has fewer parameters, and so this is the second. Like I said, that because of convolution, it will be shifted. The filter will be shifted to the next part of the image, and we will get a new filter data, a new value. And if we have, for example, like if we have another node in the fully connected layer, it means that our weight is double. From 36 will become 72, while in the CNN we still use the same filter. Okay, so CNN actually it can call the weight of in CNN is share weight. It means that with the same filter it will do for the rest of the image, the fully cover for all the image. I think that's all about my presentations, about the regression, about classification, about the neural networks. I know that this is only small part of regression and small part of classifications, because if we want to do it more detail, we don't have enough time, and I hope we will have another time to do some presentation. And if we have some time to do that, I will try to explain more detail about the neural networks. Okay. Thank you for your attentions. I hope you can understand about my presentations. Feel free to ask me. I will give back the time to Miss Lia. Thank you very much.
Thank you very much, Dr. Rizal. And this is a very interesting topic that we discussed today with our speaker from Telkom University and also from Batangas State University. It takes us, I think, years ahead. The technology that we're going to face, maybe not us, maybe our children or maybe our grandchildren. It's going to be a very important thing in the future. So we are now in the discussion session with our speaker. So kindly, so students and participants, also I noticed that there are lecturer also from Telkom University and from Batangas State University who also joined us today. So we have 219 participants today for this deep learning topic. This is amazing. So we expect that we're going to have a fruitful discussion and also many questions maybe from students and lecturers from both university. Participants, should you have questions to our speakers, you may drop the question in the chat box, or you can raise hand, use a raise hand icon, and then we will call your name and you can ask directly to our two speakers. So before, while we are waiting for questions from the participants, speakers, maybe in short, both of you can explain what is the difference. So what is the difference between machine learning and deep learning in short, in summary? Maybe we can start from Dr. Rizal.
Okay, thank you. But correct me if I'm wrong. Okay, this is my way to explain what the differences between the machine learning and deep learning. So maybe you know about the numerous number of the machine learning model like the SVM, random forest, and the others. But that machine learning is for the classification parts. And before the classification, you have to do some data processing, and like using the GLCM, for example, or the statistic data to get the features of your data. So in machine learning, you do the two parts, the extraction feature and the classifications. But in deep learning, it means that you put some layer there. It means that for the extraction feature and the classification part, only for one model, CNN. So CNN do these two parts what is it for? Yeah, so we only use one model instead of using two models. So that's differences between machine learning and deep learning.
All right, thank you, Dr. Rizal. Maybe Dr. Sarmiento want to add something to the explanation, to the answer, please.
Yeah, actually, I agree to Dr. Rizal. So, machine learning is a general term. Actually, this is a term when you want to apply or when you want to provide a learning to your computer. However, if you want to, let's say, for example, to unsound different models or to add different algorithms in a single machine learning model that you are taking, or you want to add more layers of, let's say, for example, you want in neural networks, you want to add more layers for, again, detailed feature extractions or feature selections, or you want to identify more about your data set. So by providing more layers on your model, so actually that can be considered as deep learning. So yes, I agree with Dr. Rizal with his explanations about the difference between the two. Thank
All
you.
right. Thank you so much, speakers, for the answer. So I guess I have a request in the chat box from Uke Usman from Telkom University. He or she said, can I have the subject slide in joint class? Thank you. So do you mind to share the PowerPoint or the material in the chat box, speakers? So if it's okay, kindly share the material in the chat box.
Okay, sure. Sure, no problem. I will share with me.
Okay, thank
Yes, I
you.
will also provide a copy of my presentation.
So I see that from our two speakers today, whether it's Dr. Sarmiento and also Dr. Rizal, feels like the time of 40 minutes is still, it's not enough to explain the topic that you have for today. Maybe we can have another session, maybe in the short course type, or another online joint class. Like Dr. Rizal, you explain about the neural networks, and it's just a little bit part of it that you explained, right? So maybe we can have topics about neural networks again in the
Sure,
future.
sure, no problem.
Okay, still we still have no question from the participants. Once again, so if you have any question, you may drop the question in the chat box, or you may use the raise hands icon and then ask directly to the speakers. And for those participants who ask about the e-certificate from these online joint classes, we will send you after all these online joint classes finish and complete, and then we will check the feedback. The participant who fill out the feedback that will be sent a e-certificate. So we still have still waiting for the e-certificate to be signed by Telkom University and also by Batangas State University. We will send you the e-certificate as soon as possible. Okay, do we have any question? If not, we will close this online joint class for today. Also, maybe Dr. Rizal and Dr. Sarmiento, do you mind to share your email address? Oh, you already mentioned your email address in the PowerPoint, yeah? Is that right?
Yes, I already put my email address there.
Okay, great. So if there is a participant, student or lecturer who interesting or need a further information about your presentation, they can contact you directly. Thank you, Dr. Sarmiento, for sharing your email address. Okay, if we do not have question from the participant at all for today, I hope the presentation is clear enough. It means that both of our speakers has done a very good job today. Once again, thank you very much, Dr. Rizal and Dr. Sarmiento. It's it's an honor and also a pleasure to have you both in our online joint class the second day. I guess if we don't have any question to discuss, we can wrap this second online joint class with between Telkom University and Batangas State University. Is it okay? Do you mind, Dr. Rizal and Dr. Sarmiento? Okay.
What? Sorry, pardon. What do you mean?
Is it okay if we close this online join?
Oh, okay, sure, no problem.
Okay. Once again, thank you very much for all the speakers from Dr. Sarmiento, Dr. Rizal, and and Mr. Ezel Gama for organizing this with us, and also for all participants who joined us today. I guess that's it. And I want to ask you all, I want to invite you all to join the photo session. So please turn your camera on. Okay. I hope this is not the last time we met, students and lecturers. It's been a pleasure for us to host this event with you. Okay, this is the photo session that we're going to take, the second online joint class with Batangas State University and Telkom University Indonesia on 3. In 1, 2, 3. Okay, one more time. This time maybe you can do a freestyle. Because this is the second online joint class. So, okay, on 3, 1, 2, 3. Okay, that's great. Thank you very much. So, respectable speakers and participants, I think we have had a productive and fruitful discussion together this morning. Please join me to give a big round of applause to the speakers and participants. Yes, we have shared a feedback link in the chat box. Kindly fill out the questionnaire as the requirement to get the e-certificate. I am Leah. Thank you for your attention. See you in the next event with Telkom University and Batangas State University.
Thank you very much, Dr. Dia, Dr. Inda, Dr. Rizal, Dr. Jeff. Thank you.
Thank you.
Students
so
from Bad State U
much.
and Telkom.
Thank you very much.